top of the morning or afternoon, whatever time you decide to log in. It's Coach Mike again, and I'm here with another episode of
Talk That Math Talk!
In this episode, we are going to use quadratic equations, which is anything that has the highest power of x squared, typically in the format of ax squared plus bx plus c is equal to 0. That's how we'll be able to solve and find our solutions. But we're going to find our vertex today using the vertex formula, which you'll see in the video. So I hope you got everything ready. Get your materials, your mind, and your body in position because we about to learn and then leave smarter. Let's go. Mr. Michael about to teach. Mr. Michael about to teach. Mr. Michael about to teach. Yeah. Mr. Michael about to teach. Yeah. That ain't even mine. Talk that math talk. All right, so we are looking at finding the vertex of quadratics. Now, quadratics, anything that has the greatest power of 2, always forms a parabola. That is a U-shaped curve on the coordinate plane. What we're going to do is look at, if we didn't have a coordinate plane at all, how could we find the vertex? The vertex is always the point of change. That is the point in which symmetry happens, where it bends. It's obviously going to be either the maximum or the minimum value, but let's find out how to find out what it is. The formula for a vertex is negative b over 2a. All right. Now, b, remember, is going to be the x term, the coefficient for the x term. So what I'm going to do, you don't have to do this if you don't feel like you need to, but when we're learning something, we want to be as detailed as possible at the very beginning. All right. So that's a, b, and c. So what we're looking for is negative b, or the opposite of b, over 2a. That's going to get us our x value. All right. That's going to give us our x. So let's go ahead and find out what that is. We have negative b, which is negative 24, over 2a. That's 2 times 3. All right. Negative 24 over 6. Okay. And negative 24 over 6 will give me, good job, that gives me negative 4. This is my x value of my vertex. This is x for my vertex. All right. So when I'm over here, my vertex is going to be at the point negative 4, comma something. So if I have negative 4 for my x value, all I need to do now is plug negative 4 into the equation where I see x. That will give me my y value. All right. So that is going to be y is equal to 3 times negative 4, close, squared, plus 24 times negative 4 plus 49. All right, now let's go ahead and take care of the math. We're looking at any math inside parentheses. No. Any exponents right here. So we have negative 4 squared, which is negative 4 times negative 4, which gives me a positive 16. That's 3 times 16. Now we have a 24 times a negative 4. 24 times negative 4, let's say 4 times 4 will give me 16. 6 carry the 1. 4 and 2 is 8 plus 1 gives me 9. And that's a negative 96 because that's a positive 24 and a negative 4. That's negative 96 plus 49. All right, as we continue, we have 3 times 16. 3 times 6 will give me 18 plus that 1. And 3 times 1, that gives me 48. Minus 96 plus 49. All right. Let that breathe for a little bit. Okay, so now we're looking at what is the value of 48 minus 96. Now 48 minus 96, we're going to be left with a negative because it's more negative than positive. I'm taking away more than what I have. And 48 minus 96 will leave me with 48. But it's going to be negative since I had more negatives. Plus 49. All right, now since my signs are opposite, that means I'm going to subtract, and my answer will take the sign of the larger absolute value. So negative 48 plus 49 will give me just plain old 1. All right, so that's the y value of my vertex. X is negative 4, y is 1. So my vertex will be found at negative 4, comma 1. Cool. But sometimes it'll look like this. All right, but what if we have a negative b already? Like, does the equation change at all? No, it doesn't. It doesn't change at all. We are still going to have our formula is x is equal to negative b all over 2a. Because remember, that negative sign tells me the opposite. That negative sign tells me the opposite of b. Whatever the value is for b, it's the opposite of that. All right? So in order to find my x, I'm going to look at this again. This is a. A is negative 2. This is b. B is a negative 16. And this is c. C is a negative 35. Okay? Now I'm substituting in the values that I'm going to need for the equation. A negative 16, make sure you're careful, over 2 times negative 2. Now remember, this negative is a part of the formula already. And this negative 16 is a substitution for b. So the b is just somebody who plays the b position, and negative 16 substitutes in to that position. All right? So I have a negative 16, which is just, that's right, that's just 16 over a 2 times a negative 4, which is a negative, I'm sorry, a 2 times a negative 2, which is negative 4. Cool, and now I divide 16 divided by a negative 4 will leave me with negative 4. That is my x value of my vertex. Come over here, just keep the formatting the same. My vertex is at negative 4. And now I'm going to use this value to plug into this equation to find out what my y is. All right? So I have y is equal to negative 2, negative 4 there, squared, minus 16 times negative 4, minus 35. All right. Negative 4 squared gets me 16. So that's negative 2 times 16. I have negative 16 because there's negative still there. Times a negative 4. 4 times 6 gets me 24. 4 carry the 2. 4 plus those 2 more gets me 64. That gets me positive 64. Minus 35. All right, let that breathe. And now I'm gonna multiply. Negative 2 times 16 gets me a negative 32 plus 64 minus 35. I have a negative 32 plus 64. My signs are different, so I'm gonna subtract. 64 minus 32, and the answer takes the sign of the larger absolute value. All right, so that gives me a good job. That gets me a 32. Is it positive or negative? That's right, it is positive because I have more positives than negatives this time. minus 35. So now I'm subtracting 32 minus 35. I will end up in the negative because I'm taking more than what I start with. Good job, that's negative 3. That is my y value for my vertex. So my vertex for this particular parabola will be at negative 4, comma, negative 3.
Ta-da!
Really quick before we leave this page, I want you to notice something. My leading coefficient, or the beginning of my equation, or the equation, or the coefficient that has the x squared attached, for this one is negative. That means that my parabola is going to open down. It's going to be like a frown. All right? And when it frowns, that frown is going to bend at negative 4, negative 3, which we're going to see in a little bit. But I just want to let you know a couple of other key factors of a quadratic equation. And on this one, my leading coefficient was positive, so it's going to open up like so. And it's going to bend at the point negative 4, comma 1. So this will be my minimum for this one, and my vertex will be a maximum for this one. But again, we'll get into that in a little bit. So we're here, and the purpose of this example is to show what if my leading coefficient isn't visible? Like, what if we don't have anything there? Well, even if you don't see it, it's still there because the coefficient tells me how many of each variable I have. This is literally 4 x's, and this is only 1 x squared. So we have a x equals negative b over 2a. I don't see it. That means it is 1. B is equal to 4. C is equal to 5. So it's negative 4 over 2 times 1. Okay. So it's negative 4 over 2. Which is just negative 2. That is the x value of my vertex. Okay, all right, okay, all right. So my vertex is at negative 2, comma. We're going to substitute this negative 2 into this equation. Y is equal to negative 2 squared plus 4 times negative 2 plus 5. Mr. Michael, why did you put the negative 2 inside parentheses? Well, because just out of habit or out of format, I want to show that I took an x out and I put negative 2 in. When I took it out, it left a hole, and then I plugged that hole in with the negative 2 so that I can see. Also, if it's a negative, I don't want to confuse this negative with anything else. I want to let you know that x is negative 2. So negative 2 was substituted in as x, the whole thing. So I'm not just squaring the 2, I'm squaring negative 2. All right? Negative 2 squared, negative 2 squared will get me a positive 4, because a negative times a negative is a positive. We have 4 times negative 2. Good job, that's a negative 8. Plus 5. 4 minus 8. Good job, that's a negative 4. Plus 5. And negative 4 plus 5 will get me. Good job, that's 1. Y is equal to 1. Boom. My vertex will be found here. And to see if you were paying attention at the end of the last one, my leading coefficient is positive. What does that mean for this parabola? It's going to open. That's right, it's going to open up. Boom. Making negative 2, 1 is my vertex. That's going to represent a minimum. Good job, because that is the lowest part of the parabola. Okay, a bit of an extension. What if there's more I wanted to figure out? Like, what if I wanted to know exactly what this parabola would look like? Like we've done these pieces before. We found the vertex, we found the solutions. We know the minimum, the maximum. We know if it opens up or opens down. But what about the rest? Like, I don't want to just draw you for nothing. What's the rest gonna look like? Man, I'm glad you asked. Here we go. The first thing we need to identify is my leading coefficient. It is positive. That means it will open. Good job. It opens up. We're just gonna get all the details of this thing first before we even get to it. All right. Now I need to find my vertex so I can know where it bends. X is equal to negative b over 2a. All right, since we're a little more experienced, I'm not gonna bring down the ABC. You can if you want, I'm not. All right, so that's a negative 12 over 2 times 2. That's negative 12 over 4. That's negative 3 is my x value. For the sake of space, I'm gonna continue over here. That's my x. Y is equal to 2 times negative 3 squared plus 12 times negative 3 plus 16. Negative 3 squared will give me, that's right, a positive 9. So 2 times a positive 9. Don't put a plus sign just yet. We don't know. 12 times a negative 3 is, good job, a negative 36 plus 16. Okay, all right, okay. So I have 2 times 9 will get me, 18 minus 36 plus 16. Okay, okay. 18 minus 36 will give me, that's right, 18. But it is going to be a negative 18 because I'm taking away more than I have, okay? It's negative 18 plus 16. Good job. That is a, negative 2 is my y value. All that to say, my vertex will be found at negative 3 comma negative 2. Okay, so that's a good place to be. Let me scoot this over a little bit, kind of out of scope. Didn't know that before, but now we're here. Okay. So all this math helped me get my x value for my vertex, then my y value for my vertex. So I know a little bit more about my parabola now. It is at negative 3 comma negative 2. Go ahead and add it to my key factors. I'm gonna solve this case in a little bit. I'm not about to keep just looking at this, not understanding what it is. So let's figure this thing out. My axis of symmetry, that is a line where it folds, where it creates the same thing on both sides. That is gonna be an x line because parabolas either open up or down, symmetric on both sides, so it's gonna fold in half vertically. And all of my vertical lines are x equals whatever. So whatever my x value is for my vertex, that's gonna be my axis of symmetry. X is equal to negative 3. Okay, so we know a little more. We know it opens up. We know that the vertex is at negative 3, negative 2, meaning it's gonna fold in half at x equals negative 3. Okay, I can see it in my head a little bit. I see it. All right, okay. All right, let's get a little more. My extremum, or my place of extreme, either my highest number or my lowest number, for this particular one, it is going to be minimum or a maximum. Well, if it opens up, that means all of the values are going up. So my vertex would represent my, good job, represents my minimum, because it's going to be at the bottom. That is my lowest point of information. All right, my lowest point, or my lowest value in this particular case, is going to be my y value, which is a negative 2. That is my lowest point of information. Negative 3 is the smallest we can put in. Negative 2 is the smallest we're going to get out. All right, my solutions. I remember this. Okay. All right, we're going to need reinforcements. All right, so now that we have reinforcements, let's say we have 2x squared plus 12x plus 16, and we're looking for our solutions. Okay, all right. If we were to do that, we actually could factor out a GCF. Yeah, we can. Yeah, we can. Always look for the GCF first. Yeah, we can. We could take a 2 out. Okay, all right. Okay, if we took a 2 out, that means we divided every part of this by 2. We're going to be left with x squared, okay, plus, take a 2 out of that. Yup, 6x plus, divide that by 2. Yeah, 8. All right. Oh, it's easier to handle now. Oh, yeah. Now, for those who are having a lapse of memory, we know that factoring is like reverse distribution. Like distribution is mass multiplication. Factoring is like mass division. Everybody's getting divided by the same thing with factoring. Yeah. All right. Okay. So we're here. We know that 2 is going to be a factor. We can bring that boy down here. We'll use you later. Not right now, though. If we were factoring, we'd need to. But right now, we need some solutions. All right? So in order to find the solution, we can look for the reverse box at this point. Now, of course, at any time, you could have used the wonderful, beautiful, amazing quadratic formula. Cue the music. Nah, we're not going to do it. All right. First in the first, last in the last, multiply the 2. We have 8x squared is what we're looking at when we multiply a times c. Then we listen to factors. We have 1x times 8x, 2x times 4x, nothing times 3 times 4. Oh, so we're done. Now one of these pairs will finish up my box because they're going to combine to get me 6x. 1x and 8x will not, but these will. So I have 2x here, 4x here. Okay. Now I'm factoring out everywhere. What can I take out of these? What factor do they share? Only the x. Only the x? Yeah, just the x here. And here we can factor out a 4. Going up, only x. Going up, they are both divisible by 2. So my other two factors are x plus 4, x plus 2. We're going to set all of this equal to 0 because that's how we figure out what our solutions are, okay? So we're here. All right, so we split all of our factors up like so and set them all equal to 0. So this would never happen. So this is a factor but not a solution. X plus 4 equals 0. So we subtract 4 on both sides. That gives me x equals negative 4. That's one solution, meaning this is going to be one place it touches the x-axis. And then the other one would be at x equals negative 2. That's another place it's going to hit the x-axis. So we're getting a little more information about this here, this graph. All right, so let's slide the reinforcements out the way real quick. Let's remember x equals negative 4, x equals negative 2. Get that out of the way. So these are my solutions. X equals negative 4 and negative 2. All right, my y-intercept. Now, if you remember that any constant in these equations, that's going to be my y-intercept. Meaning if x is 0, y is going to be 16, because that's going to be 0, that's going to be 0. So my y-intercept is going to be 0, 16. All right. That gives us a little more information. We know it opens up, has a vertex of negative 3, negative 2. Can you see it in your head? Okay, good, good, good. Axis of symmetry obviously is at negative 3, so points on both sides are the same distance from here. It's a minimum. Negative 2 is my smallest y. it hits the x-axis at -4 and -2, and it will hit the y-axis at 16. But there's a lot of points in between that, though. All right, so let's look at our table of values here. Okay, my table of values, since I know my vertex is -3, -2, then I'm gonna put -3 in the middle. All right, and if I substitute it in, that'll be 2 times -3 squared plus 12 times -3 plus 16. And I know the answer is gonna be -2 because I've done that math already. And my point is gonna be -3, -2. There. Cool. If we're symmetric, I'm gonna look at 2 points on each side and see what that is, okay? So I'm gonna just do -2, -1, and on this side, I'll have -4, -5. All right, now watch this. This is gonna be cool. I ain't gonna lie to you, it's gonna be cool. Here we go. I say I had 2 times -1 squared plus 12 times -1 plus 16. Go ahead and use your calculator on that, but if you don't need it, listen up. -1 squared gives me 1. 2 times 1 is 2. 12 times -1 is -12. So I have 2 minus 12, which is a -10, plus 16. That gets me a +6. So my point is going to be -1, comma 6. Okay. Okay. All right. Okay. Let's say I put in -2. 2 times -2 squared plus 12 times -2 plus 16. All right. Okay. All right. -2 squared gets me 4. 2 times 4 is 8. 12 times the -2 is -24. 24. I'm sorry. So I had 8 minus 24 is a -16 plus 16. That gives me 0. So then I have the point -2, comma 0. Now I know some of you all are kind of noticing something, and that's good, and we'll talk about it in a little bit. But I'm glad you noticed something. I'm glad you noticed. All right. Let's look at this side. I have 2 times -4 squared plus 12 times -4 plus 16. -4 squared gives me 16 times 2, that's 32. 12 times a -4 gives me a -48. So we have 32. What did I say, 32? No, we have 16 minus 32, which is a -16. Plus 16 gets me back to 0. And again, if you notice something, man, you are dope. I'm proud of you. Because it's about patterns in this thing, man. Matt Trucks told me it's a pattern. It's just a pattern. You find a pattern, you can plug any number, any letter, any animal, and it all applies the same. All right? So if you see it, man, you're dope. Keep that up. If you don't, you still cool, man. Just keep watching and you'll catch on. Now let's plug in -5. That's 2 times -5 squared plus 12 times -5 plus 16. All right. -5 squared is 25. 25 times 2 gets me 50. All right. Now over here we have 12 times a -5. That's a -60. 50 minus 60 will get me, good job, -10. -10 plus 16 gets me 6. Now, by now, you should notice, man. Hold up now. It got the same. So is at -2 On one side is 0, the other side is 0. One side is 6, the other side is 6. Because this right here is my vertex, meaning my axis of symmetry happens here. This is where everything flips. Right here. Right there. Also, you should have known that these two were going to be 0 because my solutions, or my x-intercepts, or my zeros, were at -4, -2. There it is right there. Okay? Now what does this look like though? I'm glad you asked. Reinforcements. All right, so I have myself a coordinate plane with 7 everywhere, because 7's a heavenly number. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. No. It's okay. It's okay. All right. So we tried. All right. So now let's look at our actual table of values. Okay. I'm going to slide this up so I can have it. Let me get it all. I want it all. Everything I do. I want it all. There it is. Okay. So these are my values. -1, 6. -1. 1, 2, 3, 4, 5, 6. Boom. -2, 0. 1, 2. Boom. -3, -2. 1, 2, 3, 1, 2. Boom. -4, 0. 1, 2, 3, 4. Boom. -5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Look at that. Oh, yeah. There it is right there. And now let's connect this thing here, and it makes a parabola. It looks like that. Now it does not stop there. It continues to go in this formation. Look at that. God damn. Vertex, my axis of symmetry, my solutions. My y-intercept is going to hit the y-axis at 16. That's an extension, my people. But that's that. Gang.